Bonjour. Hi, Randall.
Hey, Henrik, how's it going?
Great weather. Everything's fine.
Good.
And you?
Getting over a cold.
Well, that's almost over then, I hope.
Yeah, well, I'm a lot better than I was last week, but you know how like when you get a cold and you blow your nose too much and then you start bleeding out of your nose uncontrollably? That's
all right.
That's the part I'm at.
Yeah, I hope you get well better. You get well soon.
Yeah, me too.
Hey, Henrik, can I join? Randall, hope you feel better. I can hear your cold in your voice. Your pain.
Thank you.
Yeah. So just before everybody joins, Henrik, John asked me to forward this threat modeling call. A couple of folks at CDE who are good with the SVPs and technical leads in the threat modeling area. Maybe he's hoping that they can help us.
Cool.
One of them had responded and wanted to check and see if how his availability fits in. So I just forwarded that, and I will advise if that works out. Maybe I'll request Khalil or somebody from an OpenSSF to send him the invites if possible, rather than me sending from my personal emails. Yeah. So just wanted to give you a heads up. Yeah.
All right, but I think the invite for the OpenSSF meeting, this should be in the OpenSSF calendar anyhow, right?
Yeah.
So
yeah. Just so this first time they've been informed about it, so just giving a prelude, and once they have a hang of it, they can just find it on the OpenSSF calendar.
All right, great, thank you. Yeah, looking forward to that.
Sure.
I guess we can just maybe start right away if you don't mind.
Yeah, B is in Prague, so he's not going to be here today.
He's in where?
In Prague.
In Prague. All right. Sorry for. All right. Yeah, it's a nice spot. I wish I would be there as well.
Well, he's over at the embedded convention. So DLF, like at most companies, has also cut travel. Not completely, but quite a bit. So he's enjoying the fact that he gets to be not in his office.
Yeah, no, I've never been there. Must be a beautiful, beautiful place.
See, me personally, I kind of got traveled out when I was in the music business. And I don't know, you could say that either I'm getting old or I just love Los Angeles that much. But I can pretty much get anything I want in Los Angeles, and I can get it at a price, and I can get it like now. Just say.
All right, I think we don't go down this road. Maybe it's easier to talk about threats to development environments than sorting.
Well, they're always trying to get me to travel, and that's always been my excuse about like, you get me out of my environment, then I don't know. So yeah.
Great. So for today, quick update on what has happened since we have been together last. I'm sorry. Oops, my phone rang. Since we have been together last week, so the one thing is, so for Bian suggested to actually change the name because he found it a little bit misleading, and I agree. I mean, this was just a kind of the first title that we put there, and it's worthwhile to clarify this. So with a little bit of back and forth between Bian and John and myself, John suggested threat model of enterprise open source supply chain. I find it definitely better than what we had before, and hopefully clarifying a bit what we are doing here. My proposal was far too long. So unless there is any objection, or I would go for this.
Sounds good to me. I agree that it's better than what we had before.
Can we move the words around and just put enterprise open source supply chain threat model? Do we need the threat model of, just making it simpler?
I find it this way simpler because it says in the beginning what it is rather than needing to go through the whole. I mean, I know this from the German language that very often you need to read until the very end of a long sentence to understand what's going on. But yeah, maybe that's why I prefer this way around.
That's why I also find this, because of the languages, right, that I come through. I'm a second language, right? So I move around and find, something more understandable for me, but it makes sense when you say that. Yeah, sounds good.
All right, then I'm going to change this later. No need to do this now. The other thing is on request of John, who went through the document and left a couple of comments. I updated, maybe just let me share my screen so you. Sorry, I think I need to take this call. Excuse me for a second.
Yeah.
We do have the document link in the meeting invite, but I can put it here just to give a quick look.
Yeah, thank you. Let me open it.
Yeah, sorry, I have to go down for a minute. There's somebody going at the door. Excuse me again. I hope you can, you have the link. Please go on. We'll be back in just a moment.
Sure.
Yeah, back again. Sorry for that. You hear me? All right. So John wanted to clarify a little bit the assets of this thread model, and so I added a little bit of kind of 1 or 2 sentences for all of the 5 or so assets that we discussed in the past. Again, please read through it and let me know whether this is clarifying what is to be protected here. I mean, it's the 5 bits are basically all the proprietary source and binary code, which is including kind of resource files, default configurations, and so forth. Both stuff that is ending up in the final software product, as well as all the intermediate artifacts that are created and produced and used throughout the development process. And then the system infrastructure, which is configuration settings for any internal systems, Helm charts, Ansible playbooks, Docker files, and the like. Mirrored third-party code that is included or that is used throughout the development. Systems in the sense of any systems involved in product development and service operation. And then credentials and secrets. So again, read through it and let me know and whether there are any comments. And another, and I'm going to share. All right, you should be seeing my screen now. Another change, or what I looked up, maybe a few of you remember the discussion from last week where we discussed with Bien about private repositories, and that so far in this architecture diagram, we just have commercial providers. And in general, it is nicer to, in fact, have open source examples rather than pointing to certain vendors. He was mentioning Yocto at the time. And so I looked up a little bit Yocto, but as far as I understood, this is more like related to creating custom Linux systems for embedded devices. And it seems to be a whole tool set and methodology or so, which is why I don't think it's a good example for a private registry that you would run within a development organization. And so the best alternatives, I looked a little bit around, and where is the comment now? There are a couple of other examples. So there is Archiver from Apache, but that seems to be that had a focus on no, I guess I'm not sure whether this is the right link here. There was one from Apache and one from the Eclipse Software Foundation, but both were either only focusing on Maven or OSGI in particular. And so they were very narrow in scope. And also they don't seem, one of the Eclipse project has been archived, and for also the one from Apache, if I'm not mistaken, didn't look so actively developed any longer. The best example I have found for an open source internal package registry is called Pulp. And I wanted to know and discuss with you whether you have a good example, or whether anybody has any experience or ever heard of somebody using this Pulp. So you see here on the screen, it's an open source solution that is supporting a variety of different ecosystems in a kind of plug-in extension manner. So if you scroll a little bit below, you see they support Python, Maven, I think also NPM packages, also Docker images, but also RPM and Debian packages. So I think in terms of scope and ecosystem supported, that looked pretty good. Any feedback? You ever heard of this thing, or you ever even used it?
There's a few that do this type of thing, Henrik. I've heard of several.
But would you say that they are large? They are large scale large scale organizations? Because from my familiarity, at least, large scale organizations would use probably proprietary software to do that.
It really depends on from what era of Linux you're really talking about, because yeah, like that's at least my experience. And it really depends on how much technical debt you kind of want to incur. Because like there are very large companies like Rackspace, for example, that use Gentoo. Why? Because they want to actually maintain all of the packages they use. When I say maintain, I mean, for example, actually like have a registry of patches that get applied to certain pieces of software, and they maintain all of that. Nowadays in the modern world, you really don't need to do that. Ever since Red Hat came along and kind of basically sold everyone the idea of a company doing that for you. I mean, Debian is the same thing. You have a community that does that for you. So it really, I think, depends on like how much technical debt you want to incur, what your technical proficiency is. If you have abilities that came post cloud native or pre cloud native and post cloud native, I think all of that has a lot to do with it.
So in other words, first of all, I understand that nobody knows or has ever used this particular thing, right? And I agree that large companies, at least the ones that I know, they typically go for those commercial vendors. I completely agree here. But I'm not sure what are the reasons, in fact, because for other technologies, they very well go for, and in so many cases, they go for open source solutions, such as Jenkins, for example.
In my experience, it's always been every single organization that I've worked at in the past couple of years has used JFrog. They've either run their own Artifactory instance off of like their own hardware, or they've used JFrog's hosted solution. And I presume the hosted solution is just because, you know, then you don't need to deal with hosting even, right? Like if you buy in this day and age, right? If you like pull something off yourself, you've got to or if you pull it from open source, you've got to host it yourself. And it, you know, from a risk mitigation perspective, you know, people keep considering that, well, if you built it, you probably did the best job of securing it. So like we will hand that risk off to you, and we will just pay you money so that you can own that risk.
Yeah, you know, this kind of it's more convenient in that sense if you just rely on some cloud provider operating the thing for you. But again, I mean, for other technologies, that is not really the case, right? So I think there are still a good number of Jenkins systems out there in the industry, even though it also requires running this locally on premise. But maybe this is just legacy, and the general trend probably is also towards cloud services and providers as well in this space. All right, so maybe this discussion can be concluded by saying we don't have really a convincing or a good or a widely used open source internal package registry that we could use as an example in this picture. All right, fair enough. Good. Then I wanted to go through and the other change that happened since last week is basically that John added a couple of threads, namely here in the build system space. And I wanted to go over those and discuss with you, maybe add details or likelihood or and so forth. So the first thing, and he was quite detailed here, was about tampering with the existing build steps. Adding additional build steps or tamper with the order of, so here this is more, you know, tampering with the order of the steps in the pipeline, tamper with the final build check control. And that, I guess, these are all threads that he added, which I think depends a little bit, of course, on how the build system is set up. But which either require basically modifying the pipeline definition, which means committing a changed tempered version into the source code control system, or in more classical environments, having kind of maybe the authorizations log into a web front end and then temper kind of manually through a UI with a build process definition, right? I wonder, what do you think? Is this the right granularity, or should we rather? Yeah. So what do you think about those? I also will give you a few seconds to read through the thing.
Can you repeat the question, Henrik? Because I was blowing my nose when you said the question.
Question for me is, yeah, basically feedback on whether on those threads that were added by John, I think last week, Wednesday or so, when he was working on this, in terms of granularity, do we want to distinguish between, you know, manipulating a single build step or changing the order of several ones, or maybe tampering, as he said, with this final build check control, or whether we stay more on a coarse granular level and say, okay, tamper with the build pipeline definition, which is kind of including those different things. I'm a little bit undecided
I would say that there's a little bit of a difference between what John added and where we were at, because everything John added is actually very good and it's on point. However, I kind of think that the road that we were going down before was based more on, because something happens, this other thing can happen. Because to tamper with a build step, I mean, yes, that's a bad thing, but I think first you would have to figure out like where the threat is coming from, because what you're doing is you're stating essentially like this would be a bad thing, and there's a lot of bad things, but like how does one go about doing that? Because I would actually argue tampering with a build step, I mean, it depends on what the build system is, how they have it set up. I mean, there's a lot of things there. Whereas before we were discussing specifically, for example, Git and how Git leaks details and what can happen because Git leaks details of certain users of the system. So I think it's a little bit of a different perspective.
Okay, so what you say basically, or let me try to rephrase this. The way we approached it before is more like kind of that would be the consequence of, for example, somebody making a malicious commit. So suppose there's malware running somewhere on the computer of a developer, or and he would make a commit with which he would change the build step order, right?
Correct.
So in this sense, tamper with existing build step, as long as it is configured through, let's say, a Jenkins file or GitHub Actions, can be done with a malicious commit, and it is kind of covered by what we had before.
So it's almost a matter of prescriptive versus descriptive, right? Because one is more prescriptive and the other one is more from like a descriptive point of view. So I think it just depends on kind of what point of view you're looking at it from. And I think that some of it might be good to think about, just because different people have different ways of looking at it. So prescriptive might not be the best way every single time. Maybe adding a descriptive element in there, although I kind of think we cover that, but it just might be something to maybe better clarify and whatnot, so that there is more of a descriptive element to it. But I would say that what we were doing before is more prescriptive in the sense that it's kind of like directly addressing something, whereas John has taken more of a descriptive route where he's describing things from like a higher level. And I don't know, in a way, Henrik, it's something to also think about, because, you know, we've talked about how like in this group that we're not moving fast enough. So maybe with John's ideology, it could be more broad and that would help us move faster.
Yeah. I just wonder whether it will make it more difficult to come up with controls, right? So that is just one, if this is a high level description of what can go wrong in different ways, it will be difficult to come up with controls here, I think.
Right.
But do you think it makes sense so if we say all those things here, tamper with existing build step, change the order, change the final check control. So as far as this is done through pipeline configurations on Git, this is covered. As far as this can be done with maybe insufficient access control on a build system, such as, again, a Jenkins system, that wouldn't be covered yet, right? So the threat here would be maybe more that insufficient access control on build system, and then the malicious actor could basically abuse this vulnerability, this wrong configuration, and tamper with the steps here in the UI.
Or you could tamper with it on the fly as well.
or on the using the REST API of the respective
Well, I mean, you could always
systems,
target
so.
the build machine, like the little build machine they give you, and you could go that route. There have been people that have done that in the past.
Like what? Do you have an example?
Yeah, like that's why GitHub actually, basically tells you if you're going to use their build systems that they are public build systems. Don't build anything that's like not, or that's pretty much not public because of that same very fact. Because like this, it goes back to the whole thing of are containers really secure? So
Yep.
yeah, basically, long story short, there have been people in the past, malicious actors is what they've called them, that have done different things. I don't think they were ever specified what was done, but basically that's why GitHub will tell you like the public machines they offer to build on are really kind of for like open source and like things that are public. If you want something private, they really don't recommend using their public build service. People still use it, but it's just their recommendation is to not do it because there have been things in the past where people have acted in as bad actors.
Okay. So how do we move on with this one here, or with those three that we have in front of us?
So Randall, if I'm understanding right, it's a little bit on the broader scope here, and our direction is to be a little bit more, granular.
All I'm saying is that before we were talking about Git specifically,
only specific one, and if there are those aspects or components that we can keep the overall structure and then address the specific one that we want to approach, that might make it easier, like the Git for now.
Correct.
And then make it a little bit more approachable and actionable item, and giving this as a purpose and scope, like a broader one.
Correct.
Yeah,
you are absolutely correct.
got it.
Yeah, because like with this, this could all be generalized with somebody tampering with your build pipeline. However that happens, I mean, that's the threat. It could be that even you use a third party and they got compromised. And yeah, I mean, and that's also happened. I don't know if it's ever happened to like a CI/CD, but it has happened to like different clouds, right? Where they've lost like information and they don't know what happened to it. So like I would say that anybody that compromises your build pipeline, I mean, it's compromised, so they could do any of these things. Now we were talking about like Kubernetes as an orchestrator, that's different. If we were talking about Ansible as an orchestrator, that's different. So you see, this is what I'm saying about how like before we were very prescriptive because we were talking specifically about Git. And now, and this is more generalized. So I do see benefits in what John is doing. However, this is where I think we should start thinking about like, are we going to be talking about Git, or are we going to be talking about things like at a broader level, like build systems? If your build system is compromised, this could happen. And this is what you should look into. Version control. If your system is compromised, this is what happens. This is what you should look into. It's a little different. You get what I'm trying to say?
Yeah. Right. It's a pity that he's not with us to share his thoughts.
Because we also discussed this too, Henrik, about like being very specific about what we were recommending. Because remember, we had the talk with Bean about how like we're focusing on how like commercial companies use open source and software. So for the scope of this document, if we were to say that most people use GitHub Enterprise, then that would be okay. But you see, like So in a way, we did kind of go down that path of being very explicit about what we were covering, but I don't disagree with what John is saying, because I feel like with what he's saying and how he said it, in a way we should consider it, because it might be a better way to go, just from the point of view of trying to get to like a final document. Because if we're going to start talking about every single build pipeline that can
it will just take us
exist
forever.
Yep.
Yeah. No, but I think, so first of all, we discussed in the past to not look at GitHub Enterprise, but to stay vendor neutral here. But secondly, I think we can say whenever the pipeline is managed and controlled through code, it is covered by what we have before. And so in order to maybe integrate John's contribution, we can still assume, I think, in a technology independent way, there is a build system which has some users have some kind of some permissions and access and for some access control, and we relate to the threat of those, due to wrong configurations, wrong permissions, actors could interact with the build system.
Correct.
So here so this is maybe a compromise for how to move forward on those ones here. So
because almost what John is saying, it doesn't matter which build system, as long as you have a build system, this can happen. And before we were saying, if you have Git, this could happen.
Yeah. Let me just write a comment here to reflect this and discuss it and have John's feedback also. So when done through Git.
So yeah, we were doing Git, and I think that if we kind of go down the road that John's going down, then that would be version control. It doesn't matter which version control. It would basically be like version control, because that would be what John's talking about. Because a build system doesn't matter which build system base, but it's a build system. It could be susceptible to these threats.
Okay, so build process defined in via UR.
And obviously, I would argue that the other thing about it with John is that, yeah, you lose a little bit of specificity, but I would argue there that when the end user that is reading this, he would just maybe to some degree have to think about what is applicable to him or her and what type of build system him or her are using, if that makes sense. Because they would probably be very edge case type scenarios. Because, yeah, I don't know that many people that use Mercurial, to be honest with you.
Oh.
However, point being, even if you did use it, our paper should still apply.
Okay, so then maybe we can say we keep this granularity, we keep those 3 threads, but we specify that this is done through accessing the build system or the build system's API or UI and whatever it exposes, in order to avoid the overlap with this malicious commit way of doing the same thing, achieving the same thing.
I'm not opposed to that.
So tamper with existing, or maybe let me go to suggestion mode. Oops. Tamper with existing build system through the build systems API or UI. And then basically it's the same here. Even though I must say, I wonder how many build systems there are still out, or any feeling for how, because nowadays everything seems to be managed, only all the build systems or build pipelines seem to be managed through code, right? Any feeling for, more old-fashioned systems being still out there?
Like Make, Ninja, Meson, those systems?
Or old Jenkins configurations where the configurations live with the system.
Exactly. Yeah, that is what I had in mind. So I know Jenkins is maybe the most used system, or the one that is mostly used of the old ones. Mm-hmm.
I can guarantee you that any technology that did exist in the past is heavily used somewhere because someone has not spent the time to migrate to newer technologies, and it is still chugging along nicely. And as long as it's not broke, nobody's going to fix it.
And you also have to don't forget the zealots that also have their Make systems, and every time you bring up Jenkins, they cry bloody murder.
Okay.
And
Right.
and correct me if I'm wrong, Jonathan, but Make is a build, like a build system. Jenkins, I would argue, is like a build pipeline. I think there's a little bit of difference.
You would use Jenkins to invoke your Make file.
Correct.
Yeah, so this is so my feeling, Make would be a tool that is used during a build on a build system, right? During a build job.
It's mostly considered a build system. I would argue that like Jenkins is more of a build pipeline. Because Make itself, all it really does is just configures your build so that your build basically runs a certain way. That's all it really does. And Ninja and Meson are the same thing, just slightly different and faster. Newer generations of the same thing.
The last thing that he put here for the build system is compromise build tool, build script, build plugin. This is again pretty broad, I think.
I think that would be like a third party compromise, like a third party something or whatever, maybe. Because if it's a tool, plugin, or script, it would be something that you didn't build, right?
Yeah, I mean it's so compromise build plugin. Again, thinking of Jenkins, I know they have their own Jenkins marketplace, if I'm not mistaken. And Jenkins, there are so many Jenkins plugins, and many of them do have known vulnerabilities. And so there's a lot of room for compromising, builds through those plugins, if I'm not mistaken. But then again, the build script depends on whether, again, maybe managed by Git, and so then it would be covered. And build tool is, for me, I don't know, another binary installed on the build system that is invoked by the build script, right? So which can be compromised maybe in a different way. For example, by accessing through the operating system and tampering with this one through this way with it. So I wonder whether it makes sense to split this a little bit.
I don't know. It's true build systems don't work like build pipelines, because build systems basically, if you can invoke it, you're good. It's building basically. So I agree there is a slight separation there. Because essentially, as you said, if you can get to the build script, you can build it. So I think the build pipeline is what offers, for example, access controls and all of that stuff. But then you would be talking about DevOps. You wouldn't be talking about like Make, because Make, all of that came into existence long after Make was a thing. like, yeah, it follows Linux ACLs and that sort of thing, but like, yeah, I don't know. Jonathan might have good insight, seeing how he's seen so many repositories. Sorry for
I'm not
putting you
I'm
on the
not,
spot.
no, I'm not on. I didn't realize I'm not unmuted. Anybody wants a fun image of what I'm working on right now? I'm currently tapping a hole for my boat. While I'm on this call. Yeah. Anyways, so the question was like all the builds. Yeah. So, sorry. Repeat the question again.
So basically, what we were saying is, should we separate like build pipelines from build systems? Because build systems, like Make, for example, you just invoke them, and if you can get access to them via privilege escalation or whatever, basically it's building. But with build pipelines, you have ACLs and all that other different type of stuff. So should those two maybe be separated, because the security threats are slightly different between the two?
If you're purely looking at it from the perspective of like, are the risks? So are we looking at it from the perspective of what the risks are, or what the results of an attacker being able to compromise them are, right? Like, if you can, purely the ability to invoke some build is not necessarily completely a risk, right? Like that. I mean, it may be. It may lead to exposure
Sure.
of sensitive information, like or of like proprietary information, right?
Mhm.
But it's not necessarily
A problem in and of itself.
yeah, a problem in and of itself. It's the execution in the pipeline where you're actually releasing the software, right? The ability to tamper with the make file, right, is a risk if you are able to commit it and contribute it back, right? Because then you can tamper with it, but then that's checked into source control and it's traceable, right? And actors are less inclined to want to be, attributed unless they are able to compromise another user, like another developer, to act as their front for the attack.
So actually, Jonathan actually brought something up really important, Henrik. Build pipelines can release software. Make and whatnot does not. It just basically builds it for you.
Well, I mean, it depends. It can release the software if you've added, like, I know that there are still many a developer who they use CI/CD pipelines, but the frequency at which they release their software is so infrequent that they're like, okay, I'm going to set up the publishing pipeline and I run that locally on my machine only.
Fair.
I have the feeling we have here a different understanding of the terminology here, which is adding quite a bit of confusion, I must say. I mean, a build pipeline for me is just, a sequence of different steps that can be defined either through a Jenkins file in code committed to Git or any other, or which is defined in a build system specific database according to its schema, like in Jenkins in the old times when you did it. So pipeline is just a sequence of steps. And during the sequence of steps, you would invoke a number of different tools. So tools would be such as Maven in order to, compile and test and also deploy your artifacts if they pass all the tests. Or maybe a build step, pipeline step invokes Make at some point in time. And Make, for me, I mean, system is a very generic term. For me, it's just, a tool, a thing that is invoked during a build or a build step as part of a pipeline.
Correct.
And then the last bit, and for me, the build system is for me really kind of the operating system on which all of that runs. Could be in like a physical box, could be a Docker container, could be a container managed by Kubernetes or so.
I would say that basically Make's main focus, at least when it was created from my understanding, was for you not to have to invoke the super long, like terminal command to make your software. So that way it basically would do it for you. And it would configure it for you. But all of that came long before we were able to have, like, I would say, like, legitimate configuration files for a build pipeline. So I think in the community, at least the way I've read it, most of the time a build system is one of those three: is Make, Ninja, or Misa, or I don't know how to say it, the new one that everyone's talking about. And then a build pipeline is more of a DevOps thing, and that is, that I said, that's separate from the build system, because like you said, it can invoke several tools. Usually all of these tools invoke a compiler, usually GCC or Clang. Obviously we're a C based, but yeah,
see this.
I don't work in distros, not me.
All right.
So I would say, Henrik, that like what you're talking about was post cloud native, and I think that this is very important because that we get right, because there are a lot of people in the community that think that we're very tone deaf to everything that happened prior to cloud native. And that we disregard those people. So I would argue that, like, it is important that we get this distinction right, because this is where a lot of people have problems with OpenSSF and what we put out, because they think that we don't think about anything that happened prior to cloud native.
Yeah. All right. So maybe to translate.
By the way, there is also a cost associated to running pipelines. So theoretically, if I'm a malicious actor and I have a way to trigger your pipeline, then I could incur cost, right? It could be a cost kind of attack.
I didn't get the very first bit. So there's a
cost which is associated to running a build, to running a build pipeline. There is infrastructure which is running, a compute which is running the steps.
Okay, so the attack here would be to basically trigger meaningless
exactly
build jobs just for the purpose of consuming compute resources.
Either consuming resources, or maybe I'm trying to stop you from running your own real build because you need to release a fix, right? And I'm preventing that from you because I'm using all the infrastructure.
All right. I think that is definitely something separate that we didn't have here, right? So this would be just kind of trigger. So trigger meaningless builds to exhaust resources or incur costs, something like this.
Yeah, great, thanks.
Yeah, I guess one way would be to, in fact, commit stuff to continuous commits, each commit triggering a new build, and then basically you have a long queue of things that have to be processed, right? Yeah. So in potential, okay, so actually I'm mixing here again things. Potential impact is legitimate jobs are not executed. Resources. Exhausted and consume or cause costs. So, but one step back. So here so if we say one thread is that GCC, the Java compiler, and other, things invoked during a build pipeline are tampered with, right? You would do this, I suppose, or one way of doing this would be by accessing, but again, depends on the build system, right? So let's say
I actually have a better definition from Bean because I'm chatting with Bean. He says a build system runs on a developer machine. A pipeline is usually something that like is installed in the source code directory that monitors the source code. So i.e. a build system cannot be auto triggered. A build pipeline can. That's the difference.
Let me just let me add a comment so we capture this here.
He says that it's also a CI/CD or CI/CD pipeline. It's not necessarily called a build pipeline, if we're going to be correct with our terminology.
So your definitions are basically a pipeline runs on no, let me start here.
A remote machine, basically
runs.
It's a remote machine that monitors the source code repository and can be automatically triggered when a new commit is basically sent. And then a build system is usually something that runs on the developer's machine to develop or to compile the software. So you could almost argue that the build system would be part of the developer machine threat, but even though it's kind of still used in build pipeline, but you get my point. That at least from
okay. Yeah. I think I'm getting closely to your definitions, but then again, when it is run and triggered by a pipeline, it is still a build system.
It's still remote, yeah. So I'm not saying the community definitions are perfect, but I'm trying to keep everyone happy. But I do think that's a good distinction, is build pipelines are not automatic. CI/CD, I'm sorry, build systems are not automatic. CI/CD pipelines are.
Yeah.
And that, because I think that's the threat, right? Because it's one thing to compromise the developer's machine and to compromise the build system. It's something that's separate when you have a remote machine that's monitoring something, and then you could basically get away with certain different things, basically.
All right, so let me take another perspective. So suppose I want to, maybe in an attack comparable to SolarWinds, I would like to tamper with such a build job, so that I think in the SolarWinds case, there was the legitimate source code was replaced just shortly before compilation, and then the legitimate code was restored after the malicious code has been compiled. So if I wanted to, let's say, tamper with any of the tools invoked during the build job, say GCC, in a typical system, I think that holds even true for Jenkins. that you basically have your Docker containers being spun up, and then it's within this Docker container that you would run the actual build, right? So where the clone happens, where the compilation happens, and so forth. And so in that sense, in order to tamper with it, one way would be to basically for the attacker to change the image
Correct.
that is pulled when the build, let's say, or let's use names, when Jenkins instantiates a new container.
That is correct.
So a very concrete attack would be that images, no matter where they are taken from internal or external registries that are used for builds, are tampered with, so that basically, malicious Docker images are used. And this could happen if, for example, they only reference the latest rather than a specific digest or so when pulling the image.
Correct.
Okay.
Do you want me to give you an example of like a build system compromise?
Mm-hmm.
It'd be a good example, simple example would just be compromising the developer's machine based on the software they have installed. And then basically at that point, I mean, it's not just a matter of build pipeline. You can do whatever you want, but yeah, you could change it. You could change things on their computer where they're compiling software with your special patched version of GCC, and they would never know about it.
Yeah, but I mean, the software that is produced by the organizations that we talk about, they would not, I hope, build any software on any developer machine, but that is only happening on dedicated machines, right? So the kind of tempered, modified versions of GCC on the developer laptop don't matter so much, maybe. Hopefully.
It depends on if that developer is releasing software or not.
Yeah, that's what I wanted to say. There should be okay. Well, maybe we can make this a separate thread then. I would not expect any company to have, the distributed software being built on a single developer machine. I mean, I know that this is, yeah, okay.
I think it depends on what language you're using and how it goes. I mean, like in JS, for example, it's very typical that you have a lot of packages that are built by a lot of developers and they're just sent to a registry. So I think it depends on how you have it set up, in all honesty. But yeah, but going back to like build pipelines, traditional build pipelines, yeah. I do know people that do release software, quite a bit of people. Now most of them are community members, they're not commercial, but
it's that is what I meant. I mean, for the open source community, for the open source community, I'm well aware that there is a long tail of small projects probably that builds it on the laptop basically before uploading to NPM and PyPI and so forth. But I would think that for commercial organizations, they have dedicated systems to build the software. But I think it's worthwhile to call it out. So in this sense, okay.
I think it still happens enough, Henrik, where it makes sense to call it out.
Okay, so then here it's the compromise of a build.
I can't name certain people, but I know certain people have like commercial packages, and then you look at who signed them, and it's a random person that works at X company. So yeah.
Okay, so how do we want to call this thread? Is the thread give me a name for that.
I would just almost just say compromised build system, because I mean, I think that it's a very specific thing. Okay, which could be an offset of like compromised developer machine in general.
Yeah. Okay, so then what about compromised build system on developer machine? And so here, the first control to make this very clear is don't use a developer machine in the first place.
Yeah, exactly.
And then still you have to harden then the build machine wherever you build it.
And that might actually be part of our developer machine threats, maybe.
So this is Sash, by the way. So this is like you have. So what are the attack surfaces here? So you have all the plugins like Eclipse IDE plugins and everything. So they are the source. They can be the source of backdoors. So weighting and selection of all those plugins associated with all the development tools used by the developers. So that can be compromised. That is one. And second thing is secrets. Developers machine holds a lot of secrets, like connecting to builder tools. So the leakage of those secrets can also be a threat.
This is we have this already. So basically here we have somewhere here leaking of
The leaking
exfiltrate
I think we have
exfiltrate developer secrets. So this is basically stuff running on the developer machine can exfiltrate PGP key, GPG keys, SSH keys, API tokens, whatever he has there. So this is covered. The thing before were vulnerable plugins basically, right? Right? Did I get it correctly?
Yeah. Can you come again once? Sorry.
I said so. The exfiltration of secrets is covered, and the topic you brought up before was basically vulnerable plugins, right?
Yes. Vulnerable softwares and the plugins. Yes. So that.
Okay. So. Can be exploited or attacked. Okay, I've copied those into it. We are a little bit over time, but if you don't mind, I would just spend some additional minutes in order to at least finish the description of those things.
Yeah. Description would be basically modifying the build system in some way the developer can't tell or doesn't notice. That ultimately modifies the release build. And for the record, Henrik, just so you know, I see this a lot in driver production. Like because I've done a lot with drivers, like the driver development habits of people that make drivers is abysmally terrible. Because you got these random people that'll sign it with like their personal key, and you're like, where did this come from? Like, what is this? Oh, don't worry, it's from Intel. That makes sense.
Okay, and so you say in particular driver development is happening on and the creation of the distributable archives and binaries is happening on developer machines.
Yeah, and this is also why we still, like in Linux, we still have really, really old drivers, because basically the million people have contributed a million things to them. So yeah, like it gets really, really hard. And in as far as Linux is concerned, there have been issues in the past with drivers and people basically having very bad habits on their machines, losing machines. Just it's terrible. Like and it's because driver development, and that's just not in Linux, but in general, it's very messy. It's very expensive. That's what I've been told, is that it's very expensive, and that's why it's very messy, because they will try to copy and paste as much as humanly possible to try to save costs on a lot of things. And it's not just one company, it's all the companies are to blame. Which is really why they had to separate firmware from the Linux kernel years ago, because firmware cannot be trusted, because it could literally come from anywhere. And sometimes it does. That's the other funny thing. that sometimes it does. Sometimes it's not from the company directly. And then you get these drivers and they're just from some random guy that spent 2 months trying to figure out how something works. And there you go. And then everybody uses that driver. And then that guy doesn't know anything about security.
Would you, do you dare to provide a likelihood, or is this, I find this
in driver development, it's very bad. I could tell you it's very common and it's very bad.
Okay, so let me just...
and if you want like specific examples, I could go find them. But if you just go to the kernel, to like the Linux kernel, and you go to the driver development section, yeah, like there are a lot of people that submit stuff. No one can verify where it comes from. They'll wait like 6 months, and then somehow it just ends up in the kernel.
All right, so good. I put this in the examples references section, driver development for Linux kernel, and also included the likelihood as high in driver development.
Yep.
I'm not sure this will cause some eyebrows to raise, I suppose, but well.
People that have worked in Linux or Linux enough, they'll know what we're talking about.
All right. The other one we just had is vulnerable, which was mentioned just before. Vulnerable plugins or appliances can be attacked to tamper with the build. And so basically here, this is the potential impact. Yeah, basically it's after all, it depends, of course, again on the vulnerability, but assuming the worst, he would kind of be able to tamper with the whole build machine again, right? So if there is a plugin that has a
let me ask you this,
execution
Henrik.
vulnerability, yeah.
Would ChatGPT, or not ChatGPT, but would Copilot? Because what I've been seeing a lot is a lot of people just, oh, Copilot wrote it, I'm just gonna use it, and they don't check things. Would that fall in here?
No, what we just write here, vulnerable plugins or appliances.
I know it's not a vulnerable plugin, but it's giving you code that would make your software vulnerable. That's why I'm asking.
Yeah.
Would that be covered in this one?
We have something like this, not exactly, but very comparable, is promote vulnerable code in developer community. So here the idea is that attackers post deliberately vulnerable code somewhere on Stack Overflow, so that people just copy it carelessly.
That's good.
So it's not exactly ChatGPT, but it is kind of maybe along those lines. People carelessly copying code around.
Maybe we can modify that next time to include it in there. It's all good.
Yeah, here eventually trying to prevent a malicious code injection, but we are talking about different source. Malicious code can come from a copy paste from a Stack Overflow, or that kind of what you just said, or malicious code can come from a backdoor from plugin or any other insecure or any other vulnerable software. So there are different attack surfaces for malicious codes to be injected. So that's what we are trying to identify.
Fair.
Okay, so then these are two different things, and so, sorry, we're well beyond time, but as long as there's some interest in continuing the discussion, I'll just keep on talking. So the first that you mentioned were vulnerable plugins. If you have that, those vulnerabilities can be exploited, and then maybe there's some elevation of privilege on this respective build machine. And then from there, anything can happen. The second thing that you just mentioned are malicious plugins, right? So this comes back to what we have, which is kind of a different thing, I would say, and which comes back to the discussions we had previously on the developer machine about, having vetting processes, approval processes that make sure you only install this version of this thing and nothing else.
Yes. So let's try to elaborate that. And I'm just talking about any other things, like, are we considering any insider threats and like a bad developer?
No, we don't do this. So we were excluding this in the beginning. We have opened the scope anyhow far too much, I have the feeling. So no, we don't do this. And so here, so for malicious build system plugins, the controls, this comes back to approval and vetting processes. And then controls here is patch processing or patch update processes.
I feel like, Henrik, that some of them could probably go under, like, we later on we can maybe either get rid of some or like recategorize them, because I feel like some of them are extensions of other ones.
I agree. We continue to see those, right? There will be vulnerable softwares all over the place. There will be the likelihood or some chance of having a malicious piece of software all over the place, and they will be condensed at a later point in time, I think, no matter where they are installed. Okay. And I think also here, compromised build system, I mean, there will be probably something like, after all, just hardening your system, which will cover, I guess, a couple of those threats. Okay. This one here was nice and new, the trigger meaningless builds to exhaust resources or incur costs. Good. Okay. I think I've covered, I put the gist of it into the tables. Yeah, it's all right. I think I'm good. Maybe another last request, and I wanted to have, I forgot when going through those in the beginning of the meeting, but when going through this stuff, I noticed we have a lot about lack of tool guidance, lack or bypass of a vetting process, an incomplete vetting process, or inconsistent internal processes and guidelines. But these are more problems of organizational processes or maybe organizational setups. This is really has a different quality than many of the other threats which are due to kind of software vulnerabilities on these kind of things. Just to note, I'm not sure whether, I guess they can also be grouped in some meaningful way later on. Yeah, maybe this was more just sharing some thoughts when I read through the document rather than really.
So if you don't mind me asking, Henrik, what is our end goal and what is like our finish line with this?
The end goal is to have, I think, a comprehensive list of threats that we can share with such commercial development organizations, and that can be linked to existing efforts, both of the most importantly of the OpenSSF, but also from other sources that can be used to mitigate those.
So, but should we come up with maybe a tangible number of like recommended? Because we said before that this is going to kind of be an ongoing thing. So I imagine that at some point we will have a tangible number of recommendations.
Yeah.
So I was just wondering if maybe we should discuss, or maybe for the next meeting we should think about that, so that way we can maybe at least start drawing a line in the sand, so that way we don't just going forever and ever and ever and never release nothing.
Yeah. No, I completely agree. Yeah.
Because I would be happy if we have like 50, or like, I know that's a lot, but I think it's a tangible number. But even if we said 30 or 20, like at least that would be enough for us to start marketing and getting the word out. In fact, I talked yesterday, I had a meeting internally with the LF. We've decided to start a new cybersecurity blog that's going to be more oriented towards hackers, and is going to kind of have a different branding, and just it's going to be oriented more towards that DEF CON black hat community. So yeah, like as I said, like this could definitely be great for those efforts, but in order to get something like that started, we have to have like a I would say version, even if you want to call it a version 0, like a draft that we could write a blog on, and maybe that would also encourage more people to come to the meetings.
Yeah. No, that's a good idea. It's a good approach maybe to already start communicating about it, which will force us to produce something, let's say, more mature, even though we know it's not complete yet.
Yeah,
kind of some mature intermediate results.
Yeah,
That's a
let
good
me
idea.
know. We should talk about that next time because I definitely have a lot to do with the LF marketing. I just have contact with them for the new blog, and I know that Jennifer Bly does the marketing at LF, and we've talked before. So we should talk about that next time about how we could start doing or drawing lines in the sand.
Yeah. No, I've talked to Jennifer in the past. I think that is, it's a good way to go. I agree. But for that, I think there's still a little bit of consolidation required here.
Totally.
All right, good. Let's call it a day for today.
Yep.
I again get well soon, Randall.
Thank you.
I hope you get over your cold and talk to maybe next week. We said last week Thursday we would still have it on the Tuesday, right? But I'm not sure whether anybody of you will be there. I guess it's July 4th, so you will be off on vacation. So don't think this makes so much sense. In fact,
a lot. If we want to cancel it, we can cancel it. A lot of groups have been canceling it. I will probably. I don't think I will be doing anything, so I will probably be around if that matters. But yeah.
All right. I will see. Maybe I discuss later on with John what he thinks about it, whether there are sufficient people. But it's good to know that you will be around. Cool.
Yeah, if you want to have maybe like a little sesh that to just maybe do some consolidation, maybe put a milestone of where we're gonna see, like first release version, we could do that.
All right. Cool.
All right.
Thank you so much. I wish you a nice
Thank you, Henrik.
day
Thank
and
you, Chad.
afternoon.
Thank you, everyone.
Thank you.
Bye-bye.
Thank you.
Bye.
Bye.